Alrighty. Welcome back to Algebra 2 with Mrs. Roberts. In this video, we're going to be looking at notes 8.3, and we're finally looking at the last two functions that we are going to have to know how to graph. So be excited about that. Last two functions that we are going to be graphing in our entire class. Okay, we're going to be looking at what we call an exponential function and a logarithmic function. And so we're going to split it in half. We're going to start with exponential functions. All right, and first we're going to start with what the heck is an exponential function. All right, well, exponential functions are functions that have x in the exponent. Okay, so an example of that might be f of x equals 2 raised to the x. Okay, that's what we call an exponential function. All right, so real quick before we talk about transformations, let me show you what that looks like. All right, so remember, you don't have to actually type f of x equals in, you can just do the other part. So 2 raised to the x. All right, and so I'll zoom out just so you can kind of see that this is the whole graph. This is a whole graph. One curve, okay? One curve that's kind of flat on one side, and then it curves, and then it looks like it kind of goes almost straight up. Okay, so it looks a lot like the curves when we were just doing the rational functions, except there's only one of them. Okay, there's only one of them, and with that being only one of them, it will actually have one asymptote, but we'll get to that in a little while. All right, so it's a curve, and that number, that 2, can change pretty easily, and the graph doesn't change a whole lot, okay? But if that number becomes a fraction, okay, yeah, if that number becomes a fraction, then the graph starts to change, but we'll get into that more in a few minutes. Okay, so this is kind of giving you an idea of what the parent function would look like. Okay, all right, so let's talk about transformations. All right, and the transformations are the other numbers that would be included in this type of equation. So here is what it looks like in its most basic form, and you can do f of x or y equals, doesn't really matter. All right, so if it has a number multiplied in front of the piece that's raised to the x, that a right there is a transformation. Okay, if it has a number added or subtracted in the exponent, that is a transformation. And then if it has a number added or subtracted after it, that is a transformation. And so I'm going to fill those in just a minute, but I want you to understand that B is not a transformation. And I mean, A and B are numbers, but B is not going to represent a transformation. Okay, so we have worked with A's and H's and K's before. So this should be a quick review. All right, H. Well, look where H is. It's in the exponent with the x. It's grouped with the x. All right, so remember, if the adding or subtracting is directly next to the x, right, that's going to be your horizontal shift. That's your right and left shift. Okay, and also please remember that plus means left and minus means right. I got ahead of myself. Plus means left, minus means right. All right, K is the number added or subtracted afterwards, after the whole rest of the function. all right? And that's your vertical shift. That's your up and down, all right? So remember, plus means up and minus means down. All right, so now let's talk about A. Well, A is actually, depending on what A is, could mean more than one transformation. For example, if A is negative, that means the graph is reflected over the x-axis. If A is negative, the graph is reflected over the x-axis. But the actual number for A matters as well. All right, remember, if that number is bigger than 1, we're going to have a vertical stretch. And if that number is a fraction between 0 and 1, we're going to have a vertical shrink. So A can tell you a lot. But again, I want to say, all right, make yourself a note, B does not make a transformation. So it's nothing. You don't tell me anything about it. All right, so pay attention. B is the actual part that's raised to the x. B is the part that's raised to the x. All right, so the first thing I want us to do before we do any graphing is to actually just practice picking out the transformations. Okay, so the parent function is y equals a number raised to the x. So B is a number. If there's anything other than that, if there's a number, another number in front of that, or a number added or subtracted in the exponent, or a number added or subtracted at the end, then you have a transformation. All right, so in number 1, I know it's tempting to say something about the 3, but that's not a transformation. The only transformation is the plus 5, and it's an up 5. All right, because look at the difference between 1 and 2. In number 2, you have 2 numbers before you get to the exponent, okay? The one inside parentheses is the B. That's not a transformation. It's the one in front of that that is your A. It's positive, so it's not a reflection, but it's bigger than 1, so it does make a vertical stretch. The 1/4 is nothing. It isn't, well, it is something, but it's not a transformation. Okay, and then we have the -1 as part of the exponent. So that's a right and left shift. And since it's a minus, it's a right shift. Okay. All right, number 3. All right, again, the number that's immediately raised to the x, that is your B. That's not a transformation. But if there's something in front of that, that's a transformation. So the negative is going to make this thing reflect over the x-axis. All right, then we've got a +2 that's part of the exponent. So that's a left. And then we have a +7 that comes after all that, and so that's an up 7. And last but not least in this little section, number 4, notice, okay, we have a number and then another number directly raised to the x. The second number here, that's our B. So the first number is a transformation, and since it's a fraction and it's multiplied, it is a vertical shrink. Okay, then we have the -4. It's in the exponent, so that's right and left, and minus means right. And then at the end we have a -4 that's not part of the exponent, so that's when we move down. Okay. All right, so hopefully you can just pick out basic transformations. All right, remember, if there's only one number immediately before the exponent of x, there is no stretching or shrinking. okay? If there are two numbers multiplied together before you get to the exponent, then the first one is going to change, is going to make your vertical stretch or shrink. And of course, if it's negative, it's going to make it reflect, okay? All right, so let's talk about the graph. All right, the parent function is just going to be something like y equals b to the x, all right, where b can be any number. As you saw in the top few examples, it can be a whole number, it can be a fraction. If it were negative, then obviously that's a reflection. All right, but it can be a whole number or a fraction. Now, that does change the graph. Okay, it does matter in terms of the graph if b is a whole number, or excuse me, a number bigger than 1 or a fraction smaller than 1. Okay, so when would you see exponential functions in the real world? Well, have you ever heard this, like in science, something like the population grows exponentially? Okay, that is an exponential function. Okay, the population growth can be represented by an exponential function. Okay, but because it is growing, we literally call that exponential growth. Okay, and that happens when the b, the piece that's raised to the x, is bigger than 1. It's bigger than 1. Okay, and so this is what that parent function looks like. Okay, it starts off really close to the x-axis and then curves. That is really bad. Let's undo that. Let's try that again. Okay, it starts off really close to the x-axis and then goes through our intercept and then shoots up very quickly. Okay, so think of it as a population. Thousands of years ago, depending on what you believe in or whatever, there were very, 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 very few people. Some people say that we started with 2 humans, okay? And then they reproduced, and then they reproduced, and they reproduced. And so the population slowly started to grow, okay? Slowly. And then the more people there were, the more people there became, like it just faster and faster, just took off, okay? Now, what you need to understand with an exponential function, okay, is that unless you reflect it, it will never be negative. It will never be below the x-axis unless you, well, okay, so I take that back, because it would if you shifted it up and down. But what you have to understand with, the parent function is that it will never go below the x-axis. And that's because there's this invisible barrier that the graph will never touch or cross. And remember, we call those invisible barriers asymptotes. And for exponential functions, they have horizontal asymptotes, which means the equation is going to be y equals, and for the parent function, that is always going to be on 0. Now, if I shift this thing up or down, that horizontal asymptote is going to move. Okay? All right. By the way, let's talk about, since I drew the parent function, notice if it has an asymptote on the x-axis, it cannot have an x-intercept, and our y-intercept happened to be at 0, 1. Okay, so it doesn't matter what number b is, if it's big, as long as it's bigger than 1, that point right there will always be at 0, 1. All right, so let's talk a little bit about the domain. Okay, so remember the domain are all the x's from left to right. Okay, well, I have an arrow that points to the left forever, and if I trace it, it keeps going to the right. I don't actually have to stop at a vertical asymptote, Okay, so that does not mess up my domain. All right, notice because I don't have a vertical asymptote. All right, so I get to go all the way from negative infinity to positive infinity. Okay, but because I have a horizontal asymptote, my range is definitely affected. Okay, because technically range is supposed to start down at negative infinity and work your way up. But there's no graph down here in the negatives. My graph starts just above the horizontal asymptote, right? So that means I start at the horizontal asymptote, but I'm not allowed to equal it because I don't touch it, and I go up forever. So it starts at 0 and goes up. And the 0, like, make sure that you understand that that comes from the horizontal asymptote. Okay? Now, end behavior. It's going to be a little bit different here. All right, we definitely have a left and a right. All right, so we do need to talk about x approaching negative infinity and x approaching positive infinity. All right, so let's go over here to negative infinity. Look at the end. Look at the end of this graph. Okay? It's going left, but it's never going to go down more than this asymptote, right? It can't decrease, can't go down past this asymptote. And so the furthest y, the closest y I can ever get to is 0, okay? Because that's my horizontal asymptote. But the other end is not getting close to the horizontal asymptote. It's going up forever. And so that is a positive infinity. So you do need to pay attention. Whichever end is getting close to the asymptote, you can use the asymptote for your end behavior. But the other end is either going to go up or down. All right. And then last but not least, you are going to have to be able to trace these things. And here, I can just use green. All right, you're going to have to be able to trace these things from left to right and get your intervals of increasing and decreasing. So x values left to right. Okay, so start on the left. That means I'm technically starting at negative infinity. And if I work my way to the right, I start off slow, but I will always increase. So this one is increasing forever. So it is never decreasing. Okay? All right. Now what happens if b is a fraction? What happens if b is a fraction? Well, we call that exponential decay. And maybe in science you might have heard like elements have half-lives. And that means they literally break down into half that amount over a certain amount of years, and then half that, and half that, and half that, and so on. So we call that exponential decay. And that happens if our b value is, hold on, I don't want to just say less than 0, because I don't want you to think, less than 1, because I don't want you to think it can be negative. All right, negative, remember, is something else. All right, so if b is between 0 and 1, then we have exponential decay. All right, so let me go, okay, so on Desmos, remember we said, okay, what if we made b a 2? All right, and so that should look like the parent function we just talked about. But what if I make that number a fraction? Oop, 1/2, and I want to raise it to the x. Okay, now look at it. All right, it's actually, it basically flipped it over the y-axis, but we won't even get into all that. It just changed it from, here's my 2 raised to the x. It changed it from a function that starts off flat and goes up to a function that actually starts from the top and comes down and then gets flat. Okay? All right, so again, the one I'm looking at here is my decay, where b is a fraction smaller than 1. All right, now I know I put 1/2 here, but I could put any fraction there and the y-intercept will still be 0, 1. All right, so let's come back over here. All right, and let me see, let me try to be consistent. All right, so my y-intercept would still be at 0, 1, and there would still be no x-intercept because I still have a horizontal asymptote at y = 0. The only difference when that number is a fraction is that the graph will start high, start big, and gradually get smaller, right? Decay means get smaller, okay? But remember, we're never going to cross that asymptote. All right, so the good thing about that is that a lot of things don't actually change. All right, so when I do my domain, we're talking about the x values from left to right. Right, this end technically does go to the left forever, and this end goes to the right forever. So my domain is still all real numbers. Okay, negative infinity to positive infinity. My range, well, I still don't have any graph below the x-axis. Okay, so no negative numbers. My graph doesn't start till I'm right above the asymptote. And so I'm still going to be 0 and everything above it. Okay, so I'm still going to be everything above 0. So yes, I'm still above the horizontal asymptote. End behavior changes slightly, right? Because it's the right end that's flat. It's the right end that's really close to the asymptote. So it's the right end that gets the 0. And then, but when I look at the left end, that's this one over here, that one's pointing up. So that one's going to get the positive infinity. Okay, so there's some connections there. And then if I traced it, if I were to trace it from left to right, okay, hopefully you see that that one is decreasing all the time. But remember, you're doing left and right, okay? And so it's not increasing, okay? All right, so I know this video is getting long, but I do want to go through 2 examples with you where there's actually numbers involved. Okay, so what are you going to have to do in terms of figuring these out on your own? Well, you're going to have to be able to look at an equation and first decide if it's going to be an exponential growth problem or a decay problem. And please understand that you're looking at the b number, the number that's immediately before you raise to the x, okay? And since that's a 1/2, that's a fraction less than 1, that's going to be a decay problem, okay? So that is not a transformation. However, we do have a transformation, right? We do have one. If I made you list it, that would be a right 3. Okay. All right. I want you to use Desmos. I want you to use Desmos to get the x and y intercepts. All right. So I'm going to go to Desmos. Oh, good. You're welcome to throw some parentheses in there and then do, oh, now you do have to be careful when you put a number subtracted in an exponent. You are going to have to put parentheses around it, okay? So I don't know if you saw what I was trying to do, but if I don't have parentheses around the x, and even though it looks like I'm still in the exponent, as soon as I hit the minus, it takes me out of the exponent, and I don't want to do that. So I'm going to have to put my exponent in parentheses. All right. Okay. And so you can see that that is actually going to change. That is definitely going to change your y-intercept, okay? But you can slide it around. You're never going to get a gray dot on the x-axis because we still have a horizontal asymptote, okay? But I want to talk to you how to find that. All right, so my x-intercept was none. My y-intercept was 0, 8. Okay, but I do need to talk about the horizontal asymptote. Okay, well, make yourself a note. The horizontal asymptote is just the number added or subtracted, all right, after the entire exponential part. All right, so that means it's not part of the exponent. It would be the number, the stuff added or subtracted after all of that. And since there is nothing added or subtracted after all of that, it stays in the same place that the parent function had it, and that was at y equals 0. So there's my horizontal asymptote. We have a y-intercept at 0, 8, and then we just have to make it look like the one on Desmos, which was, remember, it was, ooh, that was really bad. All right, it was a decay problem. So it's got to come from above and work our way down and flatten out when we get to the x-axis. Okay, so that's what your graph should look like. Now, as long as it's exponential, the domain and range will always be, or excuse me, I say that, that's wrong. The domain will always stay the same. The domain will stay the same. And as long as we don't reflect it, as long as it stays above the asymptote, as long as it stays above the asymptote, you will start at the horizontal asymptote and go up from there. Okay? All right, end behavior. We still have to look at the left and the right. All right? One of them should get close to the asymptote, the horizontal asymptote. Well, that's the right, so that one gets the 0. The left is pointing up, so that one gets a positive infinity. And if I trace it from left to right, it's always going to either be decreasing the entire time or increasing the entire time. Well, if I trace it, starting on the left, this one decreases the entire time. And all you have to do is match the domain because they're x values. All right, now number 6, I have a lot more going on. I've got a negative in front, which means this one's going to reflect, so that's going to change my graph. I've got an extra 3, which means it's going to be a stretch. The 2, that's the part that's raised to the x. That's my b. That's going to determine growth or decay. All right, and since it's bigger than 1, it's going to be a growth. All right. I'll go to Desmos in just a second to get the x and y intercepts. But let's talk about the horizontal asymptote. Remember, that's just the number added or subtracted completely after the entire exponential part. So it's got to come after all this exponential stuff, and we have a +2, so y is going to equal 2. Okay, so that's my horizontal asymptote. Okay, and we can jump over to Desmos, type her in. All right, so I mean, -3, And I'm going to use parentheses just like I had on my paper, raised to the x. And this time I definitely want the plus 2 not to be in the exponent. Let me hit my home button, okay. And you can see what it looks like. Zoom back in. You can definitely click on 2 gray points. So you definitely have an x-intercept and a y-intercept. And so we're going to record those on our paper. All right, so let's plot those. A little past -0.5, down to -1. And real quick, jump back to Desmos. You will see that this curve is definitely below the asymptote. It's going to be below, so it's going to start off flat and then turn down. Okay, now if you think about it while you're drawing it, if you start on the left and you draw it, you can see that you're decreasing the entire time. Well, I know that it's below the asymptote, but that doesn't change the domain because it still goes from left to right, from -infinity to +infinity, and it's decreasing that entire time. So those actually should match. Now, the range is definitely different because now I'm below the asymptote. I'm not above, I'm below. And so remember when you do the range, you start at -infinity and work your way up. Okay? So -infinity is the first thing and the asymptote is the last thing. Oh, not 0. The asymptote was 2. Sorry, got ahead of myself. Okay? All right, end behavior. We still have a left and a right. All right? The left is flat on the asymptote, so that one gets the asymptote number. The right is going down to -infinity. And just one more time to get the increase and decreasing, we trace our graph from left to right, and you should definitely see that it's decreasing it's decreasing over the entire domain. Okay, whew, I know that was a long video, and unfortunately that's only the first half of the lesson, but that is how to graph exponential functions.